Hey guys, what's going on? Hopefully, you guys are starting to trickle back into Schoology and getting back into the swing of things in terms of academics. I did post a quick chat. If you guys could just make sure that you type in some sort of math equation. It's almost like an attendance, just checking to make sure people are still staying in tune with some math, just so when we do get back, you're kind of in good shape. The stuff's not graded necessarily, at least at this point. But it'll help you transition when we do get back into class. This week stuff, a little bit of like exponents and lines kind of in there a little bit. It's a new type of unit, something we may not have gotten to anyways this year. But, it's interesting to think about certainly things that could be on standardized types of tests and stuff. So, welcome back. And again, please just make sure you're following along with this stuff each day. Got a couple questions for you. And you can always ask me any questions if you got them. So what I want to do today is sequences, just sequences today. We'll get to series in a little bit. May skip the warm up just for the sake of time, but this is actually what's called the Fibonacci sequence. So you start with 1 and you add 2 and you get 3, and then you take the 2 from here and you add it to the answer you got and you get 5. And then you get the 3 and the 5 and 8. 5 and 8 is 13. Then you get 8 and 13 is 21. 21 and 13 is 34. It just kind of keeps going. It's just a random sequence that exists in the real world. It's called a Fibonacci sequence. So just some quick definitions here, right? The first thing that I want to do is say that a blank is a function with a set of positive integers. That's going to be what we call an infinite sequence, right? And I'll put that in here, infinite sequence. And it's very interesting because it's almost like a function. I mean, it is a function in a way, but you can only plug in what's positive integers, right? And those are going to represent something very specific in sequences where it wouldn't make sense to be able to plug in negatives. It wouldn't make sense to plug in fractions or anything like that, because what you're plugging in are these function values, a, b, c, doesn't matter what letter you use, a sub 1, b sub, or a sub 2, a sub 3. These are called the terms of the sequence, right? So if I just gave you a pattern of numbers, each number that I gave you would be called a term, right? So I could say, what's going to be the third term or the third number in the pattern? That's why it wouldn't make sense. You wouldn't have a negative third term in a pattern. You wouldn't have the 1.5 term in a pattern. They're only going to be positive integers, right? Because they are representative of the terms, right? If your sequence only consists of a set number of integers, meaning it's not infinite, that's what we call a finite sequence, right? So instead of infinite, it's finite sequence. And the fact, we already know this, I'm just going to skip that part, but you could have a pattern of numbers where it's the factorials, and just move on. All right, so an example of a sequence, right? So this would tell you b sub n, or a sub n, whatever letter we use, would what we call the nth term, right? So the nth term, it basically just says, okay, if I plug in the nth term, I'm going to use n, and it gives us the formula for the nth term. It's 1/2 to the nth power. So if I want to figure out what the first term, right, this b sub 1 means first term. It's like the first thing in the sequence, first number you see in the pattern of the sequence. The first term would be, what the value would be is if you plugged in 1 for first term in for n. So it'd be 1/2 to the first power, which is just going to be 1/2. The second term would be if I plugged in 2 for n, 1/2 to the second power is 1/4. The third term if I plugged in 3, the nth term if I plug in n, right? So, just practice here. We're going to write out the first 6 terms of this sequence. So the nth term is denoted by this formula, n minus 1 over n. So if I wanted the first term, which would be a sub 1, I would say that that's if I plug in 1. So 1 minus 1, which is 0 over 1, so it's 0, right? I'm not going to worry so much about graphing. It's not that important. But, a sub 2 would be the second term. So if I plugged in 2, I'd get 2 minus 1 over 2, which would be 1/2, right? And on and on and on. So the third term would be 2/3, the fourth term would be 3/4, the fifth term would be 4/5, the sixth term would be 5/6, right? So it would just be a fraction and things like that. So that would basically be a simple example of mapping out the first six terms of a sequence. If I wanted to find the 100th term, I would plug in 100 and I'd get 99 100ths, right? Here, this is an interesting thing here. We're going to see this come up in a little bit. This is, well, we can try out the numbers, the six terms. You can pause the video if you want to and do it. But if you wanted to, right, the first six terms are going to be shown. If you did it on your graphing calculator and you plugged in x instead of n, you'd get something that looks like this, which doesn't really make sense because, again, the first term is going to give you 2, right? If I plugged in 1, 1 minus 1 is 0, negative 1 to the 0 power is just 1, times 2 over 1, so it's just 2. So if I plugged in 1 first term, I get 2. Now if I plugged in the second term, I'd plug in 2 for both parts of n, just like I did with the first one. 2 minus 1 is 1. Negative 1 to the 1 power, that's going to be a negative 1, right? So negative 1 times 2 over 2, which is 1. So negative 1 times 1, so I get negative 1. So what it does is every other number, it's going to go from positive to negative. That's what this part is being responsible for. Still starts with a positive with the first term, but then it changes negative, positive, negative, positive. And then from there, you can kind of see it, right? Now, this graph is totally wrong because, again, sequences are only for integers. You couldn't connect these points together because there's no such thing as the 1.5 term, right? There's no such thing as the 2.5 term. Those don't exist, right? They're all terms, they're just positive integers. So you'd actually just plot them out, by doing, something like the second term was here. The third term would be like 2/3, and then you'd kind of just go back and forth, right? It'd just be the points. This one I'm going to skip, but you can kind of see it. It does say it's a little different because it has different rules if you're plugging in an even number or an odd number. So if I wanted like the first term, C sub 1, well, 1 is an odd number, so it would just be 1 over 1, which would just be 1. The second term would just be the number n, which would just be 2, right? So you could figure out the first six terms, no problem, I think. This is really what I want to get to today. So, I'm going to give you the first two, and then these two I want you to kind of submit to me in Schoology. Same thing, I'm going to do this one with you, and then on this one I want you to figure if you can figure out on your own and tell me what is in Schoology. So what we want to do is write out the formula for the pattern or for the sequence here, right? So the first term is e, the second term is e squared over 2, the third term is e to the third over 3, the fourth term is e to the fourth over 4. So if I want to know what the nth term is, I'm just going to write a sub n, and then I could try and figure out, okay, how can I represent this so that when I plug in 1, I get this. When I plug in 2, I get this. When I plug in 3 for the third term, I get this. When I plug in 4 for the fourth term, I get this. Right, and if you can kind of see it, this one's a little bit simpler, but it's just going to be e to the n over n, right? So first term would be if I plugged in 1, so e to the 1 over 1. Oh, that's the same thing as the first term here, which is e. The second term would be if I plugged in e2 over 2. Oh, e2 over 2 second term, third term, fourth term, so on and so forth. The second one's a little trickier here. We have, you can probably see the relationship. You can absolutely tell me what the next term is going to be in the term after that, right? This is, okay, if I divide it by 3, I get this. If I divide it by 3, I get this. If I divide it by 3, I get this. Like, that's not what the question really is. I want to know, how do you write the pattern kind of like this, right? Say, all right, well, I got 1 over 3. That could be 3 to the first power. This is 3 to the second power. This is 3 to the third power. Oh, I know what it is, Mr. Jocelyn, right? It's going to be b sub n is going to be 1 over 3 to the n. It's not far off, but the problem is that would be absolutely true if you got rid of this one, right? If this one didn't exist, oh yeah, first term is going to be 1 over 3 to the 1, which is 1/3. That would be the first term. 1 over 3 to the 2 is the second term, which is 1 over 9. 1 over 3 to the 3 is here. The problem is this 1 is screwing everything up. So if I need to like reset like a term and go backwards, what if I did n minus 1? Now when I plug in 1 for the first term, 1 over 3 to the 1 minus 1. Well, 1 minus 1 is 0. 3 to the 0 is 1. So 1 over 1, oh, there I go. I got it. Right? Then the second term would be 2 minus 1. That's how I get to the 1/3. So like this n minus 1 is almost like a, oh, it didn't start right where I wanted to start it. But now if I add the minus 1, I can actually level it off. So these next two, I think you guys can get. I want you to just submit them on Schoology for me, as well as this one. This is the opposite, right? Oh no, these are kind of the same thing. So I'm going to do this practice one with you, and then from there we'll get it. So right here we have, nth terms. I'm going to say a sub n is equal to what, right? So here they all go up by 2. It's 1, 3, 5, 7, 9, 11, on and on and on. So the difference in each one is 2, which it's kind of like slope when you think lines, right? If I said 2, 4, 6, 8, I think you guys would be able to get that. It would be, 2n, right? The first term would be if I took 1 and multiply it by 2, I get 2. Second term, 4. Third term, 6. Fourth term, 8. 2, 4, 6, 8, no problem. This, again, it doesn't start with 2, though. It starts with 1. So it's the same difference in each term. I'm just going to subtract 1, and then it resets me to the original term. So now when I plug in 1, I get 2 minus 1, which is 1. Boom. So first term is 1. Plug in 2 for second term. 2 times 2 is 4. 4 minus 1 is 3. Oh, there I go. And I'm good, right? So do these 3 questions here. Submit them on Schoology, and I will see you guys tomorrow.